Welcome to Astronomy Daily, your go-to podcast for the latest and greatest in space news. I'm your host, Anna, and I'm thrilled to have you join me today as we embark on another fascinating journey through the cosmos. We have a packed episode for you, covering some truly remarkable developments and a few unexpected turns in our exploration of the universe. Today, we'll discuss a private spaceflight mission that faced an unexpected anomaly. We'll then look at how NASA's Mars Reconnaissance Orbiter is learning new maneuvers after nearly 2 decades, offering fresh insights into the red planet. For stargazers, we'll highlight a recent nova explosion that made a previously dim star visible to the naked eye. We'll also dive into a new statistical analysis of exoplanet habitability, revealing promising candidates for life. Finally, we'll explore a cutting-edge collaboration between NASA and Australia on lunar laser communications for the Artemis 2 mission. So buckle up and let's get started. First up, let's talk about a recent private spaceflight that didn't quite go according to plan, yet is still being called a partial success by the exploration company. This incident involved their NIX capsule, which was part of the SpaceX Transporter 14 rideshare mission launched on June 23rd. Among the 70 payloads sent into orbit, the NIX capsule had a very special cargo: memorial remains contributed by loved ones through Celestis Memorial space flights. Celestis offers various tiers of space memorial services, from launching DNA into space and returning it to Earth, to sending remains into deep space. For their 25th launch, dubbed the Perseverance Flight, Celestis partnered with the exploration company's Mission Possible to carry its memorial payload aboard the NIX capsule with the intention of returning it to Earth. The mission proceeded nominally throughout, with the capsule performing as expected, powering its payloads in orbit, stabilizing itself, and even re-establishing communication after the expected blackout period during re-entry. This blackout happens when intense friction with the atmosphere creates a superheated plasma layer around the spacecraft. Everything seemed to be going perfectly, right up until a few minutes before its scheduled splashdown in the Pacific Ocean. That's when an anomaly occurred. The exploration company reported losing communication with NIX. A later statement from Celestis shed more light on the issue, confirming that the capsule's parachute system failed to deploy. This tragic failure resulted in the NIX capsule impacting the Pacific Ocean and dispersing its contents at sea. It's an incredibly somber outcome for the families who entrusted their loved ones' remains to this journey. Celestis expressed their hope that families will find some peace in knowing their loved ones were part of a historic journey, launched into space, orbited Earth, and are now resting in the vastness of the Pacific, akin to a traditional and honored sea scattering. The exploration company also extended an apology to all their clients. Despite this significant setback, the exploration company is viewing the mission as a partial success. They highlight the technical milestones achieved, emphasizing their ambition and the inherent risks involved in innovation. The NIX capsule is a crucial part of their future plans, designed to transport both crew and cargo to and from low Earth orbit and beyond. They are determined not to let this snag slow them down and are already preparing to refly as soon as possible, leveraging the lessons learned from this ongoing investigation. Now let's turn our gaze to Mars, where NASA's Mars Reconnaissance Orbiter, or MRO, is proving that you can indeed teach an old spacecraft new tricks. After nearly 2 decades orbiting the red planet, MRO is literally on a roll, performing new maneuvers to extract even more science data. Engineers have managed to teach this probe to roll almost completely upside down, a feat that allows it to peer deeper beneath the Martian surface in its hunt for liquid and frozen water. These new capabilities, detailed in a recent paper, describe 3 very large rolls executed between 2023 and 2024. This innovative approach means that entirely new regions of the Martian subsurface are now accessible for exploration. While MRO was originally designed to roll up to 30 degrees to point its instruments, these new rolls push the limits to a full 120 degrees. The main beneficiary of these extreme maneuvers is the Shallow Radar, or SHARAD instrument. SHARAD is designed to penetrate 1 to 2 kilometers below ground, helping scientists distinguish between materials like rock, sand, and ice. It has been instrumental in mapping subsurface ice deposits, which are crucial for understanding Mars' climate and geology, and are also vital potential resources for future human missions. However, Shared's antennas were mounted at the back of the orbiter to give prime viewing to other cameras, which inadvertently caused parts of the spacecraft to interfere with its radar signals, making images less clear. By performing these dramatic 120-degree rolls, the team found they could give the radio waves an unobstructed path to the surface, strengthening the radar signal by 10 times or more and providing a much clearer picture of the Martian underground. Planning these rolls isn't simple. MRO carries 5 science instruments, each with different pointing requirements. Regular rolls are planned weeks in advance, with instrument teams negotiating for science time. An algorithm then commands the orbiter to roll, adjusting solar arrays for power and the high-gain antenna for communication with Earth. The very large rolls are even more complex, requiring special analysis to ensure enough battery power for safety, as the spacecraft's antenna isn't pointed at Earth, and its solar arrays can't track the sun during the maneuver. Because of these challenges, the mission is currently limited to 1 or 2 of these very large rolls per year, although engineers hope to streamline the process for more frequent use. In addition to Shared, another MRO instrument, the Mars Climate Sounder, is also adapting its operations. This instrument, which provides detailed information on Mars's atmosphere, now relies on MRO's standard rolls for its observations and calibrations, as its aging gimbal has become unreliable. These clever adaptations ensure that MRO continues to deliver cutting-edge science, even as it approaches its 2-decade mark in space. From the robotic wonders of Mars, we now shift our focus to a celestial spectacle happening right now in our own night sky. An ordinarily dim star has suddenly burst into brilliance, putting on a powerful display that's even visible to the naked eye. We're talking about the Nova V462 Lupi, first spotted on June 12 by the All-Sky Automated Survey for Supernovae. This star, usually far too faint for us to see with a visual magnitude of plus 22.3, has undergone a dramatic transformation. Its explosion of radiation has caused it to brighten so significantly that it appears as if a brand new star is shining in the night sky. Just as a reminder, the lower an object's magnitude, the brighter it appears. Our eyes can typically pick out stars with a magnitude of plus 6.5 or greater under good, dark sky conditions. So, what exactly is a classical nova? It's a fascinating type of stellar explosion that occurs in binary star systems. Imagine a white dwarf star, which is the dense remnant of a star like our sun, orbiting very closely with a companion star. The white dwarf's strong gravitational pull strips mass, mostly hydrogen, from its companion. This material then accumulates on the surface of the white dwarf. As more and more material piles up, it becomes incredibly hot and dense, eventually reaching a critical point where a cataclysmic fusion reaction is ignited. This sudden, powerful explosion releases a colossal outpouring of radiation, which is what we observe as a nova. Soon after its discovery, V462 Lupi was reported to be visible through binoculars, with an apparent magnitude of around plus 7.9. It continued to brighten steadily in the days that followed, eventually becoming visible to the naked eye around the middle of June, with some reports even placing its peak brightness at over plus 5.5. While it was truly spectacular, the nova is now on the decline and its brightness is fading. But don't despair. You still have a chance to witness this ancient light before it vanishes from our view. The dark skies around the new moon offer a perfect opportunity to get away from city lights and hunt down V462 Lupi. We recommend bringing a pair of 10 by 50 binoculars, which will make it easier to spot the subsiding light while providing a wide field of view to appreciate the surrounding stars. To find V462 Lupi, you'll need to look in the constellation Lupus, the Wolf, near the bright stars Delta Lupi and Kappa Centauri. For precise positioning, a star chart is your best friend. You can generate one easily on the American Association for Variable Stars, or AAVSO website. Just type V462 Loop into the Pick a Star box and click Create a Finder Chart. Skywatchers in the southern hemisphere will have the best view, as the nova will appear highest in the post-sunset sky for them. For our listeners in the United States, V462 Lupi will be visible close to the southern horizon, especially if you're in states closest to the equator, such as Texas, Florida, and Louisiana. It's a fleeting but powerful reminder of the dynamic nature of our universe. Next up, let's shift our gaze far beyond our solar system to the fascinating world of exoplanets and the ongoing search for life. While direct imaging of exoplanet atmospheres or discovering systems with multiple planets might grab more headlines, one of the most powerful and often underappreciated tools in an astrobiologist's kit is statistics. It's absolutely crucial for ensuring that what we observe is real and not just an artifact of our data or observational techniques. A new paper by Caleb Traxler and his co-authors at UC Irvine has done just that, statistically analyzing a subset of thousands of exoplanets to judge their habitability. For decades, the search for potentially life-supporting exoplanets has largely revolved around the concept of the habitable zone. This is essentially a calculation of a planet's average temperature to determine if liquid water, a critical medium for life as we know it, could exist on its surface. However, the authors of this new study argue that such a one-dimensional system is too general and not practically useful for pinpointing planets with a high probability of supporting life. Instead, they propose a more comprehensive approach, looking at characteristics of both the planet and its parent star, and then comparing these to Earth, which remains our baseline for a habitable world. They analyzed each exoplanet based on 4 key parameters: its radius, temperature, insolation, flux. That is, how much sunlight it receives, and density. For the exoplanet's host star, they examined its effective temperature, radius, mass, and metallicity, which is the ratio of its iron content to its hydrogen content. Using these 8 parameters, they sorted 517 exoplanets, for which this data was available, into 4 distinct categories. An excellent candidate meant the planet was similar enough to Earth to be of strong interest. Good planet, poor star, indicated that at least one of the star's parameters significantly differed from our sun. Conversely, good star, poor planet, meant the planet's characteristics were significantly different from Earth. The final category, poor candidate, applied to systems where neither the star nor the planet fit the bill. Interestingly, the good star, poor planet category contained the vast majority of exoplanets, accounting for 388 systems, or 75% of the data set. The researchers suggest that this isn't necessarily a physical reality, but rather a detection bias. Techniques commonly used to find exoplanets, like the transit method, are heavily biased towards detecting large planets with short orbital periods, which would place them firmly in this category. They believe that with longer observational times, we could find many more planets that fit into the excellent candidate bucket. And speaking of excellent candidates, out of the entire 517 planet dataset, only 3 were classified as excellent candidates: Earth itself, Kepler-22b, and Kepler-538b. Kepler-22b in particular stands out as a truly promising prospect, with only a 3.1% difference in temperature and a mere 1% difference in insolation compared to Earth. The paper identifies it as having the highest likelihood of harboring life, making it a prime target for atmospheric observation by the James Webb Space Telescope, despite its distance of 635 light-years. While Kepler 538b is larger and hotter than Earth, it still falls within the realm of potential habitability. This rarity highlights that Earth is statistically unique, but not so rare as to require some miraculous confluence of planetary and stellar characteristics. Another rare type found in this analysis were planets in the good planet, poor star category. Only 6 planets landed here because their host stars, which were all M dwarfs, the most common stars in our galaxy, fell outside the defined habitable temperature range. However, the authors point out that despite lying outside the generally accepted framework, these candidates still have a good chance of harboring life given their other physical parameters. Many are already under observation from the James Webb Space Telescope, and if they prove to have viable habitable conditions, it could revolutionize the field of astrobiology due to the sheer prevalence of M-dwarf host stars in the galactic population. This statistical analysis reinforces several key points that astrobiologists have known for some time. Kepler-22b remains a leading candidate for further investigation, offering our best current chance at finding evidence of life beyond Earth. It also suggests that conditions on Earth, while relatively rare, are not so rare as to be a statistical impossibility or a miracle. And crucially, it highlights the significant bias in our current exoplanet detection methods towards planets that, due to their large size and short orbital periods, might not be the most habitable. As astrobiology continues to advance, this kind of rigorous statistical analysis will provide invaluable context, helping to direct our powerful new observational equipment towards the areas most likely to answer one of humanity's most profound questions. Are we alone? Now let's talk about how we'll communicate with our brave astronauts as they venture back to the moon. As NASA gears up for its Artemis II mission, there's an exciting collaboration happening between the agency's Glenn Research Center in Cleveland and the Australian National University, or ANU, to test some truly inventive and cost-saving laser communications technologies in the lunar environment. Traditionally, communicating in space has relied on radio waves. However, NASA is actively exploring laser or optical communications, which promise to send data anywhere from 10 to 100 times faster back to Earth. Instead of radio signals, these cutting-edge systems use infrared light to transmit high-definition video, pictures, voice, and vital science data across vast cosmic distances in significantly less time. While NASA has successfully demonstrated laser communications in previous technology tests, Artemis II will mark the first crewed mission to attempt using lasers to transmit data from deep space. To support this ambitious endeavor, researchers working on NASA's Real-Time Optical Receiver, or REALTOR project, have developed a remarkably cost-effective laser transceiver, built largely using commercial off-the-shelf parts. Earlier this year, NASA Glenn engineers meticulously built and tested a replica of this system at their aerospace communications facility. Now they're working closely with ANU to build an identical system, using the very same hardware models, all to prepare for the university's crucial Artemis II laser communications demonstration. Jennifer Downey, co-principal investigator for the REALTOR project at NASA Glenn, highlights the significance of this work, stating that Australia's upcoming lunar experiment could showcase the capability, affordability, and reproducibility of the deep space receiver engineered by Glenn. It's an important step in proving the feasibility of using commercial parts to develop accessible technologies for sustainable exploration beyond Earth. During the Artemis II mission, currently scheduled for early 2026, NASA plans to fly an optical communication system aboard the Orion spacecraft. This system will be put to the test, attempting to transmit recorded 4K ultra-high-definition video, flight procedures, pictures, science data, and even voice communications from the moon all the way back to Earth. Almost 10,000 miles away from Cleveland, at the Mount Stromlo Observatory Ground Station, ANU researchers are eagerly hoping to receive this data during Orion's journey around the moon, using the very Glenn-developed transceiver model. This ground station will serve as a vital test location for the new transceiver design, though it won't be one of the mission's primary ground stations. If this test proves successful, it will be a game changer, demonstrating that readily available commercial parts can indeed be used to build affordable and scalable space communication systems for future missions, not just to the moon, but even to Mars and beyond. Marie Piasecki, Technology Portfolio Manager for NASA's Space Communications and Navigation, or SCAN program, emphasizes that engaging with the Australian National University to expand commercial laser communications offerings across the world will further demonstrate how this advanced satellite communications capability is ready to support the agency's networks and missions as we set our sights on deep space exploration. As NASA continues to investigate the feasibility of using commercial parts for ground stations, Glenn researchers will continue to provide critical support in preparation for Australia's demonstration. These strong global partnerships are key to advancing technology breakthroughs and are instrumental as NASA expands humanity's reach from the moon to Mars, all while fueling innovations that improve life here on Earth. And that brings us to the end of another fascinating journey through the cosmos on Astronomy Daily. I'm Anna, your host, and I hope you enjoyed our look at the latest developments. Don't forget, you can listen to all our back episodes and find more information by visiting our website at astronomydaily.io. You can also subscribe to Astronomy Daily on Apple Podcasts, Spotify, and YouTube, or wherever you get your podcasts. And please, follow us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok. Until next time, keep looking up.